Dear colleagues, this video is about the introduction of task configuration. Multiple pools can be created under each PLC application. Under the same application, the order of execution between different pools is configured by task. After the pool configuration is completed in the task, pool will start execution periodically or be triggered by a specific event according to the task configuration. There are several rules for configuring tasks. In the application, we select the task configuration card. Double-click it to open the task configuration interface. There are several properties in the task configuration interface: monitoring, variable usage, system, events, and properties. The properties interface can display the basic properties of the current task configuration, such as the maximum number of tasks, cyclic tasks, and free tasks. The system events that users can select are determined by the actual hardware. The library files corresponding to the target system will provide the corresponding system events. Therefore, the system events corresponding to different hardware devices may vary. We click at the system event. In this interface, we can select the system events as needed, including general system events such as stop, start, login, logout, and change. For example, we select a system event for login. Next, we need to set a function name for the system event. This name shall not be duplicated with an existing pool in the system. For example, we set it as login. The implementation language is the programming language used to call the function. Click OK after the setting is completed. The login function currently set will be called automatically upon each system login. Under the monitoring properties, when the program enters online mode, in the monitoring window on the right side of the task configuration, the user can monitor the current status, the number of cycles, the actual execution time of the program, the average, maximum, and minimum cycle time, and other parameters related to task execution. For example, if we download it into the current program, we can monitor the current status, the number of cycles, the actual execution time of the program, and other relevant parameters under each task configuration. In the task configuration interface, in addition to settings, task configuration also includes the priority of execution, task initiation type, watchdog settings, and core options. Next, we'll explain them in detail. We can right-click on the task configuration, select Add Object to add multiple tasks. The configuration interface is the same for each type of task. We'll explain it with TaskE as an example. For the task initiation type, CODESYS provides task initiation types by default, including cyclic events, freewheeling, and status. After the device description file of the PLC is loaded, external options can be added. The user can select any initiation type for the tasks configured in the application. In cyclic mode, the configured program will be executed in a loop according to a fixed cycle. Depending on the program size and whether the instruction is executed, the actual execution time of the program may vary. Here, we can set its cycle period. If the actual execution time of the program is within the fixed cycle setting time specified, then free time is used for waiting, instead of executing the next loop immediately. If there are still unexecuted tasks with lower priority in the application, the remaining wait time is used to execute the tasks with a relatively lower priority. For events in this mode, tasks will be executed when the event area variable gets a rising edge. Here we can associate the corresponding event. In the freewheeling mode, As soon as the program starts running, the task will call the program, execute an operating cycle, immediately enter the next loop when finished, and restart automatically. The execution mode of freewheeling is not affected by the program's scan cycle. To ensure that the program automatically enters the next cycle, after all instructions have been executed, there is no fixed task time in this execution mode. The task execution time may be different each time, which cannot ensure the real-time performance of the program, so it is less used in practical applications. The external trigger mode can be selected and used only when the user has successfully loaded the device description file of the PLC. We can select the high-speed inputs and all rising, falling edge provided by the PLC by default to trigger the execution of tasks externally. The state trigger mode is similar to the event trigger mode. The event trigger is executed by triggering the rising edge of the event variable, while state trigger only requires the variable state of the event area to be true, and then the task will be executed. Here above is the priority. There are a total of 32 priority levels of tasks in CODESYS. Numbers between 0 and 31. The smaller the number, the higher the priority. When a program is being executed, tasks with a higher priority take precedence over those with a lower priority. Users cannot assign tasks with the same priority. The tasks of the general OC program are distinguished from those of the interface and other program logic, and should be assigned a higher priority. This is a watchdog setting. The watchdog is a controller hardware-based timing device. It is turned off by default in the task configuration, and is used to monitor program execution. For exceptions or internal clock failures, when the system crashes or the program loops endlessly, the watchdog will be triggered to send a reset signal to the system, or stop the current program of the PLC. Configuring the watchdog requires two user-defined parameters: time and sensitivity. The watchdog can be configured separately for each task. The default watchdog time is in milliseconds. After the watchdog time is given, the sensitivity should also be set. Sensitivity is used to define the number of exceptions allowed before the application or program triggers the watchdog function, and its default value is E. So the actual watchdog trigger time is equal to the time multiplied by sensitivity. The watchdog function is triggered when the actual program execution time exceeds the set watchdog time, and the current task and corresponding program are terminated. The watchdog function is generally used in applications with high requirements for real-time performance and security levels. The main purpose is to prevent PLC crashes or endless looping of programs. About task configuration, that's all. Thank you.